So our lesson is about tides. And now, if you don't know what a tide is, or if you haven't heard of a tide, you must live under a rock, because we live on the Atlantic coast. But in order to first understand tides, you have to understand gravity. And gravity is everything is pulled to the center of an object. In this case, this is the Earth. And then, whenever you have another object that's much smaller and doesn't have as strong a gravitational pull, because it's not strong enough to move the entire object itself, it can only move things that are on the surface of it. So this, everything gets pulled towards here, which is how the tides are created. Because wherever the moon is, the water will follow it and be pulled towards the moon.
So if the moon were to stop spinning around Earth,
One place would have a high tide.
one place would have a high tide constantly, and the other side would have a low tide. Or would all the water shift to that one side, and this side be empty?
I'm pretty sure God's smarter than that.
Okay.
You should be sure God's smarter than that.
You can erase all that stuff on the far side if you want to.
Okay.
Yep.
So, as Keenan said, we're learning about tides. So to start off, tides, the word tides is used to define the rise and fall of sea level produced by the gravitational attraction of the moon and the sun. But, mostly the moon because the sun is pretty far away. Tides also occur in small lakes and the atmosphere, but we're not going to be covering that today. We're just going to be doing mostly the ocean. And actually the solid crust is moved by the moon as well. But like I said, we're not going over that. So what are the different types of tides? Well, when the sun and the moon are aligned, there are very strong gravitational forces causing high tides and low tides. And they really, okay, yeah. Spring tides are one of the types of tides, but they don't really have anything to do with the season. But when the sun and moon are aligned, the gravitational forces cancel each other out, and the tides aren't as high and low as they are during spring tides, and these are called neap tides.
One thing is being pulled one way and something else is pulling it the other way. It's like a giant game of tug of war between the sun and the moon, so it doesn't go anywhere. It just kind of stays still.
So the alignment is the sun's here and the moon's on the other side. They're aligned. So the Earth is in the middle.
Well, the sun is very far away, but since it's such a massive object, it has more a gravitational pull. But since it's so far away, it doesn't do as much as the moon does.
It doesn't override.
Yeah, because the moon is way closer.
Okay.
So, spring tides. When the moon is full or new, the gravitational pull of the moon and sun are combined. At these times, the high tides are very high and the low tides are very, very low, which makes the water almost like really shallow. Spring tides are like really strong tides, and once again, they don't have anything to do with the season, so forget that. They occur when the Earth, Sun, and Moon are in a line. The gravitational forces of the moon and sun both contribute to the tides, and spring tides occur mostly during when the moon is full and when it's a new moon. So that's what it looks like. It kind of makes the Earth, the water, kind of bulge out more than what it's supposed to. And this is on your paper if you want to look.
That little cartoon, that's probably the best way
At
to
the top.
explain it right there. Yeah, the little cartoon at the
We'll
bottom.
get to that. Neap tides. During the moon's quarter phases, the sun and moon work at right angles, causing bulges to cancel each other, and this makes it smaller. The high tides and low tides, there's less of a difference that you can see. And neap tides are especially weak, and they occur when the gravitational forces of the moon and sun are perpendicular to one another. So these occur like during the third quarter and the first quarter, anytime between, when it's full or new. And like I said, that's also on your paper. So yeah, it kind of looks like that because it's not as dramatic as when the sun and moon are aligned. So lunar tides. The tides are created because the Earth and the Moon are attracted to each other, just like magnets. So one way you can think about it is kind of like magnets. They never do touch, but they are yet attracted to each other. So the Moon tries to pull at anything on Earth's surface to bring it closer, but the Earth is able to hold on to everything except for the water, because water has special properties, like different than like a regular object. It wouldn't just float out into the atmosphere. Since the water is always moving, the Earth can't hold on to it, and the Moon is able to pull at it. So each day there are 2 high tides and 2 low tides. So the ocean is moving from high tide to low tide and then back to high tide. And there's about 12 hours and 25 minutes between the two, but that can be, a few minutes, give or take, because it's not always going to be the same. So, yeah, that's on the bottom of your paper. It's kind of like, an illustration of what it... This is not accurate.
No.
So, yeah.
I thought the Earth had eyeballs.
Yeah, it does. So, tides are, as I said in the beginning, the periodic rise of falling of large bodies of water. The wind and currents actually move the water, but, like I said, the high tides and low tides are caused by the gravitational pull of the moon and sun. And it causes the oceans to bulge out in the direction of the moon. And another bulge occurs on the opposite side, since Earth is also being pulled toward the moon and away from the water on the other side. So ocean levels fluctuate daily, and as the moon travels around the Earth, they also travel around the sun, and the combined gravitational forces causes the world's oceans to rise and fall. And the Earth is also rotating, which causes more of a movement in the tides. Okay, this is our... Do you want us to read the article?
No,
Okay,
Just tell me what it was. Do you have the link on there, or what did they share about?
It's from Dr. Odenwald's Ask the Astronomer. It's basically saying everything we just said, but, more in, very much more detail. We gave you, the simpler, easier version to understand.
Well, the simplest way to explain it is the Earth is heavy. The moon is strong, but not that strong. And it can pull certain things.
But not
And
everything.
But not everything. And water is heavy enough that it can stay on the Earth's surface, but it's
still
not
be-
heavy enough that it won't move at all.
There you
So
go.
yeah, that's just what the article is pretty much saying.
Good.
So here's our facts that Carol wants to read.
Okay.
Okay. Whenever the moon, earth, and sun are aligned, the gravitational pull of the sun adds to that of the moon, causing maximum tides.
Maximum tides are big.
That's inaccurate. Lost flooding.
Since the moon moves around the earth, it is not always in the same place at the same time each day. So each day the times for high and low tides change by 50 minutes. The gravitational force of the moon is 1/10,000,000 that of Earth. But when you combine other forces such as the Earth's centrifugal force created by its spin, you get tides.
So there's a lot of other things that factor into the movement of the tides. It's not just the moon. And these are the links that we got, the websites that we got our stuff from. Okay, so yay. Now we are going to start our activity, but we are going to ask a few questions first. So what are tides? I'm just reviewing this.
That's where the sun or moon pulls the water on the earth in one direction.
Pretty much, yeah. What makes tides go up and down? Branson.
Gravitational attraction of the moon.
Yes. Okay, does the moon have gravity?
Yes.
Does the sun have gravity?
Yes.
Okay.
Good job.
So what effect does the moon's gravity have on the ocean?
Yeah, what kind of effect?
It causes it to bulge in areas creating the tides.
Okay, so we're gonna start
Get that
the
image out of your head.
activity. Keaton, you wanna show?
Yes, I'll show you. You'll pass rubber bands out to you. Everybody needs rubber bands.
Okay, it involves rubber bands, so you all need a rubber
Oh,
band.
yay.
Okay, so place the rubber band flat on their table.
It's flat.
And put one finger in the very center of it.
It's easy.
Take the other finger and put it on the inside edge of that rubber band. Now pull it around. Pull it
Not that
outwards.
tight.
Not that tight, but just enough so you can see that it stretches. So the rubber band that was in your finger that was in the middle of your rubber band would represent the Earth, or the Earth's center, and the rubber band would represent the ocean, and your other finger would represent the moon and how it pulls water away from the center of the Earth.
Yeah, the outside finger kind of represents like the force or like the amount of gravitational pull that the moon has, because the moon's going to be out here. That's just the gravity. So that's a simple version of what happens with high and low tides. And now you all have a free rubber band. Go play with them. Okay. But not in front of Miss Tutorial.
Is there a
She will
quiz?
probably not like you anymore. We have a quiz.
Oh yeah, that's a quiz.